So let's begin. So far we have seen how to create the cluster using ops, right? How to access the cluster, right? How to deploy application, right? And how to write the YML files, right? And the basic stuff that you have seen there, right? Also like how to expose those application, and all the way we can expose our application using load balancer, node port, and cluster IP, right? So we have to be very we should understand these all things. These are very essential to understand also, right? So far we are good, right? So I would like to explain the Kubernetes application deployment type, right? Basically we have two type of deployments in the Kubernetes, right? We have a two type of application in Kubernetes. One is stateless and one is stateful, right? Most of the deployment will fall under these two only, right? Either that will be a stateful, either that will be a stateless, right? So what is this stateful and what is this stateless, right? So I have just put the example here of stateless and stateful examples, right? So the stateless application are those, right? Those are basically do not have a file system with them, right? Everything you are deploying that is inside the container, it is not sharing any file system, right? But stateful application are those application which are using external devices, external volumes to deploy their applications. Right? So far we have deployed, last time if you remember we deployed the hello world, right? So the things we have deployed so far, that was the stateless applications only. So we will see in future also how to deploy those stateful applications, right? So far we have seen only the stateless applications. Remember this, right? So it may be asked in the interview also, what is the stateful application and what is the stateless application. So again, I will go with the one stateless application, not the stateful application, right? We was discussing about the services last time, guys, if you remember, right? We was talking about the queue proxy, right? How the queue proxy handle the communication between the uh, pods, because we know every time if the pod gets deleted, new pod will be generated and it will have the new IP, right? If the front end wants to talk to the back end, right? If every time the IP changing, that there is a problem, right? So the queue proxy helps us here, and it helps us to communicate with the backend, right? Using the service name. So what I'm going to do here is I have already placed, you know, you know, if you go here, you'll be able to see here, services, queue proxy. So you can go ahead and take the YML from there, or I'll take you directly to the Kubernetes documentations, right? From where you can pull that and use it. So I would like you to explore more, right? Uh, using services, right? Because I don't want you to follow just me, like what I'm doing, you are doing those things only, right? So go ahead and find the things and start doing things. So you can go here and you can easily find the documentation labs here. These are the very good things are available here, right? How we are going to deployment the back end and front end, everything is there. How to test it, all the steps are there in the very, you can see it here. If you want to test it in the Kadakoda also, sometime you're in an office and you don't have access to the Kubernetes cluster, you can go to the Kadakoda, play with Kubernetes, right? And you can set up those things here, right? So what I'm going to do is I'm going to have again the same kind of applications. So far you would have seen yesterday what we did is we deploy one application. After deploying that application or microservice, we used to expose them using the commands, right? How we used to do that? Like this, right? After deploying our YML, what we used to do is we used to like expose our application using the expose deployment port, right? Like this, and we used to use the different kinds there, either that is load balancer, node port, or cluster IP and external names, right? We can also use the external names, which is called the DNS, right? So here what I'm going to do is I'm going to deploy one microservice, right? The microservice is going to deploy one hello app. This is just a greeting app, nothing else, right? The deployment we have in this image, the application has been deployed in this image that only prints hello world, nothing else, right? So now again we are taking the API version deployment. So for deployment, our API version would be apps slash v1. Kind would be deployment. Metadata we are saying hello, right? The metadata we are, which is going to label with this, I mean deployment, would be hello. Again we are giving some specifications where we are giving the selectors and match labels, and we are saying app name would be hello, and that it would be fall in the backend tier, and track is stable. We will have a 7 replica of this image. I mean we will have a 7 containers. We are using templates again. We are saying metadata app and try tier is backend and trace is stable. In the next specifications, where we are launching our containers, we says the specification is now not the template, not the selector, but it is the specification is containers, right? We are saying we need to create the containers. Name should be should of the container should be hello, and image we are going to pull from the GCP. I mean gcr.io is the repository of the GCP, which is accessible for everyone, right? You can see Google's, it is available in the Google samples because the GC was most basically, the Kubernetes is managed by the Google itself, right? So that's what we have found, one image there, hello hyphen go hyphen gke, and the version is this, and we are saying the port should be HTTP and the container port would be 80, means this application would be running in port 80 right now. I'll go ahead and save this. I will run kubectl apply -f microservice.yml. So what it will do is it will create one deployment for me, right? And the deployment name is hello. You can go ahead and describe this also. You see what everything is there inside it. So just do kubectl describe deployment and the name of the deployment, right? If we have more deployment, you should always provide the name here. So let's go ahead and see what all the properties this deployment has. It has name hello. The namespace is default at this moment. We'll talk about namespaces later. This was created on Sunday this time, and the labels are none. Annotation says this, right? This is the deployment .kubernetes IO revision 1. This is the deployment type that we are giving. The selector is, I mean, what we can select to target, drop our traffic to this application. We can select hello, we can select backend, and we can select the stable also. The number of replicas we are going to run, desired 7, updated 7, total 7, available 7. Strategy type is rolling updates. We will discuss more about the deployments. You will come to know about these, right? Minimum ready seconds 0. Rolling update strategy is this. We will discuss about this too. And the container is this, right, which is running on the port 80. And a couple of things, you can see the conditions here also, right? Scaling replica set and these all things, right? The currently we have the 7 replicas running in, right? Now if I want to expose it, right, I don't want to expose it. If you go to the documentation also, right, that I was trying to show it here, you can also follow these instruction here, which are pretty good, right? These are the things available here. So the next, right, do you remember last time what we used to do? Everything we used to do command line. Now we are not going to do command line, right? To expose it, I will create this service microservice hyphen services.yml. Right now, to create the service, now you will understand this API version more. What I'm saying is version should be v1, right? API version means to create this, I mean to create the service we are going to use the API version 1. This is mandatory. And the kind is service. That means if you are going to create the service, we'll have to take the API version 1. If you are going to take the create the deployments, right? Like we created here, we will have to use the apps slash version 1, right? So let's talk about the services now. Sorry for this, right? So what I'm doing is I'm using API version 1, which is used for service. The kind name is service metadata. Now what I'm saying is metadata is hello, right? The specification is apps and tier. That means any traffic, right, coming here for this. I mean, anybody is trying to access the service, right? It should fall on either hello or backend, and it should open the port 80 and target it port 80. So what type we are giving here? We are not giving any type. So by default, if you are not giving any type, the application is exposed in the cluster IP only. The application will not be accessible from outside. So that's what we are directly giving the port. Port is protocol is TCP, port is 80, and the target port is HTTP, because this is the 80, right? And we are not giving any, we are not exposing it publicly or over the node port. So this service will be accessible only from within the cluster. So let's go ahead apply -f and sorry, apply this, right? So let's go ahead and kubectl get deploy, I mean service. You can do SVC also. SVC also can print the services, or you can give the complete service. That's totally up to you. So let's go ahead and describe it now. Kubectl describe service and your service name, right? So it will give you the name of the service as hello. It's on the default namespace annotation. That means what will be the selector, right? Hello and backends. So this is my backend label basically. So whatever the application will try to access me, they can directly, drop that traffic in the front end over this name, right? And by default, the application is running on the cluster IP only. IP is this, and you can see the endpoints are those, right? So let's go ahead and verify the application once. So let's see if we are going to, call this application from here. That will not be right. So generally, let's go ahead in your node. Let's go to master node directly, because it's accessible from inside the cluster, right? So admin @IP. Here we go, right? So let's give it a curl from this cluster IP. So it is printing the hello, right? That means the application is running successfully here, right? So that means the application is running in the cluster IP, but if I try to access it from outside, so this application would not be running from outside, because if you see here, expose is from the cluster IP only. There is no external IP, there is no node port, right? Now, sorry. Yeah. Now, the second I am going to create one front end, right? So that it could access the backend over the tabs or over the service we have created. So let's go to frontend.yml. So the first I'm creating one service API version 1. It says kind is service, metadata is front end, right? And the metadata for the previous one is backend, right? So here we are saying backend, front end, and specification selector we are saying app is hello and here is front end, right? So the service we are creating is front end right now, but we will say here if any traffic is coming to front end, just you can drop it to the backend. The protocol here we are using is TCP. Port we are using it 80, target port is 80 also, and the type is load balancer here. Do you remember in the previous service we just gave the type as a nothing. We did not specify any type here. It was till here only. So we are giving type here, type load balancer, because I want this application should be accessible from outside, right? You can use the node port and other also if you external type if you want. In the same YML, I am creating another deployment. So I'm giving the API version 1. So this is the deployment I am saying, and the metadata is front end, right? Specification selector are hello, front end, and stable, right? Replica is 1. So again, if you go to the specification of the container, I am taking on Nginx container, which is called the front end. So you can see we are taking on container, which is called the hello hyphen frontend colon 1.0, and we are just running this container with this command. So quit. All right. Next, we are creating on frontend.conf. What frontend.conf is doing is this is just working as a proxy pass, right? We are saying if anything is coming over the hello, right? I mean, to access the hello, just redirect it over port 80 and the location should be this. So just redirect it to the hello here. So that's the redirection we are creating. So what will happen is when the Docker build run, right? When we create this, so this will be added to, it will be added to the Docker file. These rules would be added to the Docker file and will be pasted in the .conf file. Right? If you want to see more about this, so you can directly go to the documentation here, right? If you want to see this, like how it is working in the Docker file, you can see the container image here. The Nginx configuration is backed into the container image, right? So what the configuration we have created here, right? Frontend.conf, it is just mapping inside the container like this. So it is removing the default one and it is adding whatever frontend.conf we have created. So that's what I have kept this frontend conf here as well. So which is also placed in this repo initially. If you'll have any issues, you can directly go here and you can practice from this section. From this, you can pull these 4 files from here itself for doing the practice, because it might take slowly. As soon as you practice, you'll understand them more. What I'm doing is kubectl apply -f. So microservice instead of frontend.yml. So you can do kubectl get deployment. You will see one front end deployment is there now. If you do keep kubectl get svc, you will see one front end service has been created here. Right now, whatever the communication will happen here that we have specified, you know, init conf, that will be from the backend, right? Whatever request I'm hitting here to URL, right? If you remember last time, if let me use the curl http this, it will print that. Still, I think that it is in provisioning state. So whatever request you will send to the front end, it will talk to the backend, right? It will talk to the backend services instead of the IP. So that's how the service works for you guys. I will have some more example of those later on. Let me see if load balancer has been provisioned successfully or not. Those are in service now. Let me see if this is coming from outside. So you can see this is just printing a hello message that we should get from the deployed application that we have seen initially, right? When we deploy it, we got it, right? So all the communication, guys, that will happen through the backend service that we have created now. So anytime if your pod gets created, right, if it is replacing, right, most of the time you'll see if anytime, let's say, your pods has been deleted, right, when the pod has been deleted, so it will respawn the new pod, right? But how it will come to know? So kubectl get pod. So you can see as soon as I deleted the pod, it has automatically created new pods for me. And this is the behavior of like Kubernetes, right? So every time your pods will be deleted, terminated, it will get the new IPs. But you know, you don't have to worry about it because the kube proxy is going to handle that communication for you using the service names.